So maybe we can start. Now it's already 3:01. It will be. It's my pleasure to welcome you all to the MPS 17 Food, Health and Pharma webinar. Before I introduce the speaker of the session, I would like to give the word to Sasha, and he would like to say something about the ISPT's role in MPS. Sasha, can you please unmute your microphone? And camera, if you will, Sasha. Okay, maybe we need to give Sasha a minute. Hi, Sasha, can you hear us? I think we're having a bit of microphone problems. Unfortunately, we cannot hear you, Sasha. Okay. I think it would be perhaps better for us than to carry on. So I would like to introduce the speaker of this session, Karin Schrun. And I would, the Karin has been working in Wageningen University since 2012 as a professor, and her research focuses on nano and the mesoscale, and driving the understanding from these scales. She's interested in designing food processes related to the membrane separations and emulsification. With this, I would like to give the floor to Karin. Karin? Karin, we cannot hear you now. Your microphone is muted.
Sorry for that, guys. Just too enthusiastic to start the presentation. Up, come on. All right, I hope you can hear me now and also see the first slide.
Yes, we can hear you, Karin.
Okay, very good. Well, thank you very much for the nice introduction. And it's really my pleasure to talk to you today about sustaining the future, and more specifically in relation to health, food, and pharma. And to add to my stress, I was told to do this in 15 minutes. So the challenge is on, that is for sure. And what I want to do during today's presentation is basically talk to you about sustainable development goals. That is not really very new, but how process engineers can really contribute to basically all of them. And that is also what I really honestly feel that we can do. Because if you think about process technology, a lot of products are being made that make life a lot easier. And also if I think about food, the distribution of food over the world, and also the shelf life of food is really very instrumental for a sustainable world. This is the combination that I'm trying to make today. So food, health, and also pharma. And as most of you most probably know, the picture out there is actually one of a rather healthy diet. So that is basically if we eat that, then we will live a healthy life. There is no doubt about it. But there's other foods around that are also very attractive. And if you would eat that, like, let's say, once a week, then you're still going to be pretty healthy, don't worry. But if this becomes your daily menu, then most probably you will end up in a situation where you are in dire need of pharmaceutical solutions. And it's also really good that that is in place, and it really helps make our life a lot easier. Now, the big question that I was trying to think of when preparing the presentation is like, how can process technology really be instrumental in these aspects that are actually pretty diverse? So let's start with food and food production on the land. Now, if you would have told Dutch farmers 10 years ago that they all would be owning a drone and that it would really help them in making their produce in a much more efficient way, then most probably they would have told you that you're completely off the rocker. So they wouldn't really have believed you. And nowadays, it's very standard practice that farmers do use this equipment to monitor their crops to those nutrients and in principle optimize the production that they can get from the land. So that's a big step away from the land as such. The land nowadays also becomes much more uh, glass houses and even vertical farms. And you see an example here on the right side of this slide, where you, I mean, these are strawberries that are being grown, but they're very tightly monitored. And in essence, monitoring these processes not so very different from what you would do in a factory. It's just a little bit of a different factory, and this one has an awful lot of sensing technology on board as well. So it shouldn't be very unfamiliar for process technologists, but still, I don't find an awful lot of process technologists in food, and I think that is really a chance, really an option to do something good there. Now, away from the land, and there is, of course, the factory where the food is being processed. And also there, I see big options in terms of precision process control. And if you think about pharma, then also continuous processes and innovative process designs could be one of the things that are just around the corner. If I think more specifically about food, more precise process control would also lead to foods that have less heat damage. For those that are not familiar with food processing, food safety is like the top thing that you want to have in place. So basically kill bacteria. And these are much more heat sensitive than any other chemical reactions that may occur. So if you can control the processes in a much better way, you will also end up with foods that are much more nutritious and also healthy. So also there I see big steps that can be made. Now, within sustainability and then also health realm, I also see some big steps that can be made. If you want to make a formulation, and whether that is something in pharma or in food, it doesn't really matter. It's always about the functionality of ingredients. Now, I've taken an example from food simply because that is what I do on a daily business. And what you see here is pulses, so different uh, um, produce from the land that contain proteins. And since animal-based proteins are really not so sustainable, the plant-based alternatives are actually a very interesting feature to also include in food products. But the big question is like, how functional are these ingredients? Nobody really knows, so that is also something that would need to be investigated. And not just what is the technical functionality, but also what is the physiological functionality. Here I have an example from another lab, And for example, they use a microchip to investigate how protein digestion works. And if we understand that better, we can also relate that to physiological effects in humans. So that would really be a big step forward. Now, for the last one, in terms of pharma, also there, I see some really good options. If you look at the two pictures on the right and the left one is an emulsion, which is very precisely made. And the one that I have here, it's not just an oil droplet in water, but it's actually an oil droplet with incorporated a water droplet. So it's a double emulsion, as we call it. Now, in using these double emulsions, you could incorporate your medication on the inside and very precisely dose the pharmaceutical component in a human being. Exactly the same size also prevent overdosing, for example. The image on the right is one of a capsule with a controlled release. So also there you can really do a lot. And whether it's pharma and precision release in a human body or whether it's in food, both are really viable options where we can contribute. But we, of course, we would need to understand the formation process much better. But in microfluidics, really a lot of investigations are ongoing, and also upscaling of these systems will become a reality, hopefully soon. I'm also always very hopeful. Now, away from production of things, I also feel that in testing and monitoring, really huge steps are being made. The image on the left it's a so-called organ on a chip. So here we can test the effect of components, be it pharma or food, on living cells. And that is, let's say, the next step towards health monitoring. And the image on the right is really about health monitoring, with an app on a phone or a watch that monitors vital parameters of humans. So heartbeat, but also sugar levels, that kind of thing. That is currently available on the phone. And it's really nothing more than a very advanced process tool that we're talking about. Now, what do I think that is needed for pharma, food, and also health? Well, basically, if I wrap it up in one sentence, then it would summarize as we need insight in processes. That is the case for food production. I already named you a couple of examples here. It's also about production of
Um, Karin, your microphone is off just a few seconds ago.
I will unmute. Can you hear me?
Yes, thank you.
Okay. Yeah, somehow I got muted. All right, let me just continue. So a human body, in my perspective as a process engineer, is nothing more than a very complex process, but I mean, it is a process. And if you talk about a process, oops, no, okay. Well, as process engineer, we know what the basic equations are, right? And yes, I mean, it's very unconventional scales, for sure. We're talking about micro and nanometers and very short time scales, but it is something that we know about. And also the use of advanced analytical sensors, that is also not something that we're not familiar with. We're very familiar with that. It's just that it sounds very weird that I would want to apply that to a human body. But I think, in principle, this would hold. Now, what do I see in terms of developments in food and also pharma? Um, it's very much about minimally treated foods. So basically the trade-off between safety and also fresh foods. And there, advanced process monitoring plays a very important role, and sensors. I also see that there is a big drive toward plant proteins. I already mentioned that. And what we, for example, have developed in our lab is this emulsion generator. I will start the movie. You will see droplets coming from the top and the bottom at the left part of the movie. And you see that these droplets can meet each other later on. The movie is very much slowed down, by the way. So in this way, we can look at technical functionality of ingredients, and we can do that at very fast timescales, actually very similar as they would also occur inside a factory. So I feel that we can really make a good step forward here by using microfluidics. Now, another one that I see happening is the use of sensors to prevent food waste. The image here on the right is one of apples that have a sensor. So that's the big red dot in front. This red dot is a sensor that monitors ethylene, and ethylene is related to the ripeness of the product. So if all our products would have a sensor like this, then basically we would use the food at its optimal quality, and we also wouldn't throw away food that is still ready to be used, but maybe beyond the expiration date that you see on the package, because in reality, in the Netherlands, about 1/3 of the food is simply thrown away because it has passed the expiration date, but it doesn't necessarily mean that it is wasted. And I think that this is a very nice development. All right, now I can also push it even a little bit further, because if I think about pharma and health, in the field of pharma, a lot of organs on chip are being and developed. And yes, it is for pharma, so maybe it's a little bit too expensive to be used in a food and more like nutrition setting. But given the developments that are taking place, I think that it is really possible to also develop this for food ingredients and directly link ingredients to health effects. And I think that would be an amazing step forward. Yes, I know it's a little bit futuristic, but I mean, I also want to give you a bit of a view on the future. Now, away from the effects that we then would be able to measure, I also feel that more and more development of products with controlled release will come into play, and that can be pharma and it can be food. I have an example here, the one in the middle, which is a gel bead that contains oil droplets. Now, if these oil droplets are released somewhere low in your intestine, then basically your body gives a signal back to your brain, which tells you that you have to stop eating. So this could be a way to do something about the obesity endemic that we are currently in. So it would allow people to lose weight without going to all kinds of pharma solutions. Now you see the bead in the middle. You also see that I've put a graph right next to it. And basically that is how we designed that bead in the lab. So you see the mesh size, you see the size of the bead, and you see which times the oil is going to be released. So this is very much a process engineering tool that we used to develop these components. Now, future prospects for health, food, and pharma. Well, how I see it is that ingredient functionality, physiological, and also health are going to be interconnected more and more. What I also think is that we can design products more and more from first principles. So the insights that I get on micro and nano scale are going to be very instrumental in also doing that. And then we're back to reactions and mass transfer. And yes, physiologically is much more complex. I know it. But at the same time, it is very much within the realm of what process technologies can do. So I would also really want to invite you to just join the fun and also embrace the complexity of the topics that we try to solve there. If we're able to do that, then I'm convinced that we can help people to add healthy years to their lives in a way that may be not good news for pharma, but at the same time, I feel that it really adds to the way we live our lives, and also have a much more healthy future ahead of us. And that is also what I would want to contribute to. Just to wrap up, I think that process technology, especially smart process technology, can really be very instrumental to go from farm to fork, and even much, much more, and most of all, toward a more sustainable future. And having said that, I want to thank you all for your attention. And if there's any questions, I would be happy to answer them, or as part of the thing that we're going to do later. So thank you very much.
Yes. Thank you very much, Karen, for a very nice presentation. I'm sure that the topics that you mentioned will be instrumental in our discussions with down the road with Michael and Alina. Mm-hmm. So I would like to open the floor for questions. I see the questions are coming. So if I may, I would read them for you, Karen. Would that be okay?
Yeah.
Yeah. So the first question is from my colleague Marike Klein, and she's asking, hi Karen, thank you very much for a very interesting presentation. Could you share your thoughts on how to combine reducing waste, packaging for example, with sensors to reduce food waste?
That's a very interesting question, and it's also a little bit double, because if we have a very good package, then we will reduce food waste, simply because the package protects food from wasting prematurely. I feel that if we use sensors, that we can even give the consumer information about what the actual quality is of the food inside. So that's an add-on. In terms of plastic waste, because I think that is also what you're referring to, that is really a trade-off. If we have very good food packages, the recyclability of them is something that really needs our attention, and to prevent it from going into the environment. So it's really a big trade-off. I'm currently working on biodegradable packages, and also there we are making a lot of progress, but it's very early on in the development.
So it's also possible the question like to ask their questions in person. For instance, the next question is from NAB Timmerhouse. If you can please unmute your microphone and ask the question, then I think that's also a good change for us.
Yes, thank you. Can you hear me?
Yes,
I can hear you fine.
Oh, thank you, Karen, for the nice presentation. But actually, my question was the same as the previous question.
Okay.
So it's already answered.
No.
Okay. Perfect. So any more questions, please write them in the text. I see that Marika was satisfied with your answer.
Okay, wonderful. Also, Sjoerd Klomp has his hand raised.
Yes. So if he can unmute the microphone, ask the question.
Yeah. My chat function isn't enabled. I saw online that I can fix it by rejoining. Will I get accepted if I join the meeting again?
Yes, we can
Yes,
accept you. Sue.
indeed.
Yes.
Okay, then I'll try that. Okay, thanks.
Good.
Yeah.
See you soon.
Yeah.
Yes. So maybe to go to get the discussion going. One of the if I may ask a question, Karen.
Of course.
There is now a lot of let's say interest in the field of microplastics. So there are a lot of scientific questions, where they go and where how they come in the ocean and what happens to them after. I was wondering if you think this is something that our, let's say, interest group, our MPS interest group, can contribute to.
I guess they could even contribute in many different ways. Of course, the microplastics are in the ocean as such. And but I mean that is of course a very big place to start searching for microplastics. I feel that in the design of novel packaging materials and also recycling systems, there is much more to gain. So I think you shouldn't get that into the environment. So we need to prevent it as much as possible when developing new packaging for food or for whatever, really, because the plastic is really omnipresent. And if you look at it from a technical point of view, it's really amazing that such light material can give you so much functionality. But the effects in the environment, I think, have been greatly overlooked. And that is something that is a real challenge at the moment, for sure. But also a challenge for process engineers, absolutely.
Perfect. Thank you very much, Karen. And I see that if there are no more questions, I would like to give the word to Sasha Kersten.
Yeah.
Yes.
Thanks, Burak. Can you hear me?
Yes, we can.
Perfect. And hopefully you can also now see me.
Yes, that's also
right.
Yes, nice
Good
to see you.
Hey, Burak, I did send you a few slides. Could you put them
yes.
on, please?
So luckily, Eva organized this for us.
Yeah.
So
yes.
Eva, can you please help us with showing the slides?
Yes, one moment.
Thank you. Maybe meanwhile, we can, of course, we forget one very important step in this talk. We haven't thanked Karen
sure.
for the presentation. Thank you very much, Karen.
You're very welcome. My pleasure completely.
Thanks a lot for sharing this work. And now we can officially listen, Sasha. Sasha, please.
Oh, sorry. Oh, thanks. Well, my task is very simple and very pleasant. I just want to thank the organizing committee of MPS 17, and I'm thanking them on behalf of ISPT. Next slide, please, Eva. If this works. Yeah. Now, you probably all know ISPT. If you don't, please look up our website. It's an Institute for Sustainable Process Technology. We have lots of academic parties involved, actually all the universities in this country and also some in Belgium and Germany are a member, but also most of the industry working in this field is a member of ISPT. And we run projects together at a very broad range of TRL levels, ranging from 2 to almost 7 or 8. Well, ISPT has an academic advisory board, and that contains 5 members. That's Remco Boom from Wageningen, Martin van Sint-Anneland from Eindhoven, Ruud van Ommen from Delft, Erik Heeris from Groningen. My name is Sasha Kersten, and I am from the University of Twente, and also the scientific director of ISPT. Well, one of the tasks of this academic advisory board is to make sure that MPS is organized. Well, this was always done successfully in the past. We had a small hiccup a few years ago, and then we decided to restart this very nice tradition, because I really do think it is a very nice tradition to meet once a year with all the process engineers and to talk to each other and share the new developments and so on. This year, of course, there's a special edition because we had to go online. But well, from what I've seen, this was also a big success. So thanks again for organizing. Next one, Eva. Yeah, and in particular, of course, I want to thank the organizing committee. You see the list over here, the 2 chairs, Johan and Valeria, Isabel, Hakan, Hanif, and Eva. If all is well, you already did receive or will receive a present very soon. Well, congratulations, of course, there. Well, as a last slide, Eva, as a small announcement. Yeah, this year we did this MPS online in 4 different sessions of 1.5 hours, which I think was a very good format. I don't think it's wise to meet each other online for a whole day. So 4 Wednesdays, 1.5 hours was very fine. Of course, I think that, well, meeting each other face to face is always best. I don't think online can replace face to face if we don't need to. So next year we are planning to have MPS again face to face, when we can meet each other, talk to each other, have a glass of beer, and also, of course, listen to all kinds of nice presentations. Next year, as planned this year, it will be in Delft. Well, I've been talking far too much. Thanks again to the organizers. I think it was a success. Thanks for all your efforts, and hope to see you all next year in Delft face to face. Thanks.
Thank you very much, Sasha, for these words. So then I would like to now carry to the second part of our program. It's the panel part. And for this, I would like to introduce you the panelists. If the panelists can please turn on their cameras, that would be very nice. So I would like to, well, I see Michael already in my screen, but Alina, I cannot see. Hopefully she is also available.
I did turn on my camera, so.
Okay, so but yeah, now we see you. Hi,
Okay,
perfect.
cool.
So I would like to introduce the panelists. Of course, I've already introduced Karen. So I would like to introduce my colleague Alina. So Alina has been working on a number of fields, particularly related to the controlled drug delivery and designing systems and the concepts in process engineering in the emerging fields that Karen mentioned actually in her talk. And she can give you in the discussion a better overview of the topics that she's busy with. And she recently started as an assistant professor in chemical engineering department in TU Delft after a postdoctoral appointment, and before that a PhD in MIT with Robert Langer. The second panelist is Michael Mehaus. Michael is currently working in Unilever, and he has his PhD from University of Twente, and he has taken throughout his career, he has taken different R&D roles on a range of products, ranging from the mayonnaise to meat alternatives. And we are hoping that he will give us valuable feedback, particularly from the perspective of the industry. Of course, you know that, well, we all know that we academics, we like to create ideas, but the ideas should, of course, for higher impact, should be applicable. And this is one thing that I am hoping to discuss with you. Well, we cannot see your camera. Your camera is on, I guess, but it doesn't pop up in my screen.
It's not visible right now?
At least not. Yeah, now it's visible. Perfect.
Okay, maybe I should talk more, then it becomes more top of the list.
Particularly for this panel, I think it's very useful.
Yeah.
And I'm hoping that we'll have an open discussion about the topics that we will propose, but also I'm hoping that the presentation of Karen will also catalyze our discussions. So with this, I would like to go to our next slide. Yes, so I would like to tell a couple of things about how to join the discussion. Of course, you guys might already be familiar with similar systems that nowadays a lot of the conferences that we join are and the discussions are online. And for us to manage for such a large crowd, well, we organized a system where if you would like to join the discussions, please go to polev.com and enter the password ISPT VARM TE 673. And once you do this, you will be able to join the discussions. And the way that we are organizing the discussion is that we would like to get your feedback. So we will have certain proposals. And with these proposals, I would like to hear first from the panelists these proposals, and you will be, we have done intentionally, we have intentionally not released the proposals to the panelists. And the idea was that we didn't want very scripted answers. And this is, of course, this puts pressure on Michael, Alina, and Karen, of course. And I hope it's not too much. And I would very much like to us to consider these proposals and have an open discussion. And you see that as we talk, of course, the participants are also joining. So I would like to read the first proposal. The proposal is the following: how do we feed the world in the future in a sustainable way? So this, of course, connects to the presentation of Karen. And I would like to give the word to Michael, if possible. Michael,
Yes.
Would you like to comment on this proposition?
No, thanks a lot. And I think it's a bit 50-50. Yeah, I would be quite interested to hear also what the answers for C are. But let me first give my response. And I think there's not a one size fits all solution for that. If you look at the current food system, actually a lot is wasted. So I think Karen mentioned a third of the food is currently wasted. And one of the ways to make sure that we can have a very sustainable, we can feed the world, and especially if we are with 10 billion in the future, is that we make sure that we have less waste throughout our supply chain. And I think if you want to reduce the waste, you need to go away from fresh produce more. Because if you have a fresh chain, there's always much more waste than if you have also processed foods. So I think processed foods are absolutely part of the solution for feeding the world in a sustainable way.
Yeah. Thank you very much. Thank you very much, Michael. And then I would like to give the word to Alina. And I've seen that in the presentation of Karen, there were particular points that were, I think, very much interested for Alina. Alina, if you can also tell us a bit about what you're doing and answer this question, that would be appreciated.
Yeah, so my focus is on controlled drug delivery, basically. And also on sensors, bioelectronics. So my vision is that we can build a sensor that can sense the environment real time and then be able to control a delivery system of substances where you can do on-demand controlled release. So meaning that having the system being able to be responsive to external factors such as light, such as water, such as different type of chemicals that naturally occur in the environment, and then using a sensor to verify that, as well as controlling this process. So it's like a feedback loop. So back to this question, I think there is, I would be probably more on the C category, the others category, because I think, yes, I do agree that we need to decrease the waste, but I think with more smart technology into the manufacturing or this collection of food, for example, utilization of genetic engineering on food products, or even using more controlled release systems, as well as this sensor controlled release closed loop system, we may be able to use the resources a little bit, I would say significantly more efficiently. So I do hope that because it has been shown that industrial foods or processed foods do have negative effects on health, and coming more from a bio background, I do hope that in the end we can feed the world on something so less dependent on processed foods, put it this way.
Yeah, thank you very much, Alina. So I will, in response to what the Michael's question on what the public thinks in terms of seed, I hear that I see two answers, particularly from Anna. She is saying that circular agriculture would be an alternative for seed. Before I give the word to Karen, I would like to just go over these answers. And also Frank Smets is saying we shall put more emphasis on the use of fermentation processes to create new food stocks based on non-food-based materials. So I find this quite interesting. So if Frank, if you would like to unmute your microphone and say something about this before I give the word to Karen.
Yeah, sorry, I had to find the button. Yes, Frank Smeets, pleased to meet. I recently came across an interesting article on this, and a friend of mine has put already a lot of emphasis on it. Fermentation opens new roads to transform non-edible food stocks into edible food stocks, and that creates a lot of new possibilities. In fact, it's a way of creating new proteins, and well, there's a lot of literature coming along now these days, so that's why I mentioned it.
Yeah, thank you very much, Frank. So you're, just to be sure, you're more in favor of C, so to say, right? You're proposing this as an alternative route. Yes, thank you very much.
Because I understand industrial food is the transformation of agricultural into industrial processing and manufacturing and growing of food. So that's different from C.
Thank you. Thank you, Frank. So I would like to give the word to Karen. So I hope that, Karen, you had time to recover after your talk.
Oh, I'm doing fine. I'm always doing fine. Don't worry. Yeah, it's interesting to also think in terms of fermentation as being part of the solution. That is for sure. If you say fermentation, just to check if I have it exactly correct, Frank, are you really talking about fermentation, or are you, for example, also thinking about growing algae as a alternative protein source?
Now, growing algae is, in my appreciation, industrial food production. I'm talking specifically about fermentation. A new company has been set up now recently in the Netherlands on this, and they do quite interesting things.
No, the question is not whether that could be interesting, because fermentation is a very old technique.
Yes.
And it has been used to make foods palpable and also last for much longer. Think about cheese or yogurt. I mean, that wine, beer, whatever. All these products are made by fermentation. It's not that necessarily everything you can ferment. So there's also a danger involved in fermentations. But if carried out in a proper way, it could absolutely be a way to add to the realm of foods as we know it currently.
Yes, thank you very much, Karen. So with this, of course, we are crunched in time, so I would like to go to the next proposition. So the next proposition is the following. Please vote again. What kind of innovations are necessary in the food industry? Well, that's a very interesting question, of course, particularly for. Then I think we should start with Michael. So I will read the options so that you have time to vote. Develop low-cost, nutritional, and pleasant food products for populations from low and middle-income countries. So that connects well to sustainability issues and the circular, perhaps, society. And then develop food-based, less refined products. Full decomposition of products to its components should not be necessary. The option C is develop plant-based nutrition instead of, oops, so we, Eva, if you can zoom back, yes, thank you. Develop plant-based nutrition instead of animal-based nutrition, dairy, eggs, and meat. Growing cell cultures for meat production without animals. And the other. So, Michael, would you like to comment on this?
Yeah, so I think I see two clear winners, A and C, and I'm happy to say that are also two of the things that we are working on. That doesn't mean that the others are not good. I think there's still a big part of the global population who doesn't get from their food the nutrition they need. So I think there is a need for instance, fortifying products, and actually not only in developing countries, but also in developed countries, there are still some deficiencies. And plant-based, I think if we talk about sustainability, it's crucial that we go more and more into plant-based products. And I must say that for a process engineer, that's also a very nice field to work with. So if you're used to making mayonnaise with eggs already for many years, and you now go and develop plant-based mayonnaises, for instance, based on aquafaba, the chickpea that is used, or based on different types of proteins. So I think it's a very relevant field, and lots of interesting jobs for process engineers here as well.
Yeah, thank you, Michael. And so maybe if I may ask a bit more information on mayonnaise. So let's say you gave this nice example of mayonnaise that we know basically how to do it, but then once the feed source changes, fundamentally, what kind of properties changes, and what do we need to understand better?
Yeah, so there's actually quite a few things that change. First of all, it will have a big effect on the taste of the flavor, the texture of the product. So in the end, you want a consumer. There's a certain part of the consumers who will buy it just because it's vegan and they are willing to make a compromise on taste. But I think the majority of consumers does not want to make a compromise on taste. Yeah. So there's work needed to make sure that with these new ingredients you get the same nice flavors, nice texture that people are used to. So that's on the ingredient part. But also on the processing itself, if you go into a factory and if you make it, if you have soy protein or whatever protein as your emulsifier, or whatever emulsifier you're using, you will find out that you need to adapt your process, because it will not run in exactly the same way as it used to run in the past. Especially not, it will especially not run with the same efficiencies like that. And you do want to end up in the end with a highly efficient process. So you do need to make some adjustments there.
I see. It connects very well to the points that Karen made in terms of, I think, heat and maybe sheer sensitivity of software systems, right?
Absolutely. Yeah.
Thank you very much, Michael. So Alina, would you like to comment on this proposition as well?
Yeah. So honestly, I think all of them are very important. So I will because Michael already put emphasis on A and C, so I'll talk about D, the growing cell cultures for meat products without animals. I think that is pretty important. For me, I think there is this really requires a collaboration between scientists and engineers, where I think we need to learn more about the structure and the nutrition that is within a natural food product, and the engineers will need to it's the engineers or process engineers' task to be able to rebuild that together and in the most economic way possible, so that we can grow these without the use of animals, which is, to be honest, a huge waste and a pollution source. So I think D is very important as well. That's my take. Yeah.
Yes, yes, I agree very much, Alina. I think also while trying to understand these fundamental questions, we can come across things that we didn't think about. For instance, one can imagine your field of interest, which is drug delivery. Maybe we can learn systems that are more suitable for a given drug delivery problem. Thank you very much. And Karen, I would like to give you the word to you last, and then jump into the next one.
Yes, I really like the questions and the options and how people really respond to this. So I want to share like an overall thing with everybody. Of course, we can think about many innovations, and they're all relevant. Don't get me wrong here. But what we really need to think of is how we can do that at a scale that is useful for the entire world, because we're talking global. And it is simply huge, and it's absolutely true that also in the Western world there are deficiencies in because of food nutrition not being taken enough from our foods. In a third world country, the situation would be very different, and also there I would want to help solve things, and that also there the health aspect comes back in again. But what I notice in what I'm doing is that making healthy foods that are attractive for people on a grand scale is really a huge challenge, and to also make it affordable for many people. And it's very easy for us to think from a Western perspective, but doing this in a country where maybe even the power is not on always, it's huge. It's really huge.
Yeah, so intimately, it might also lead to frugal engineering solutions, perhaps.
I'm all for that.
Yes, thank you very much, Karen. So I would like to give the word to Stefan. Stefan, would you like to unmute your microphone and ask a question?
Yes, thank you. Yeah, so I was really wondering, do we actually really need these cell cultures as a whole, instead of just replacing the important ingredients from those cells that we need in our diet?
And then maybe can I ask a clarification question? Replacing it with what?
The important substance, like I don't know, vitamins or proteins or the things we get from the cell cultures. Yeah, as a feed.
Yeah, when I saw this question, I had to think about a visit I had a while ago with a colleague, and actually it's an Indian colleague, and it was in the time that I started working on meat alternatives. And actually this Indian colleague, he said he's a vegan already for his whole life, but he has an habit, a diet which does not include any meat alternative, of course. So they eat a lot of beans and lentils and whatever. So that's their habit, and that's a perfectly healthy healthy diet. But I don't think that every consumer who's now eating meat is willing to make such a fundamental change to their diet. So in order to make sure that you can go into more vegetarian or vegan options, but do not need to fundamentally change your diet, I think there is a need for an in-between product. And the meat alternatives, for instance, like the vegetarian butcher is marketing them already for quite a few years. That's one way, one alternative, and I think that's doing very good for many people. And maybe the cell cultures could be another alternative. I think it's always good to give people a choice.
Okay.
Yes, thank you very much. With this, I would like to go to the next question. Eva, if we may. Thank you very much. So now we change a bit gears, if you will. We go into pharmaceutical manufacturing, an area that is partly continuous manufacturing, something also I enjoy thinking about. The question is, what will be the major challenge for continuous manufacturing of pharmaceuticals? So I would like to give the time for the public to vote on this. And perhaps we can now change the order where I bother our panelists, and I may start from Alina. Alina, would you like to comment on this?
Yeah, so I think continuous manufacturing of pharmaceuticals is definitely the next major step for pharmaceutical companies, especially those that are still reliant on the batch process. So I think I would go with C, actually, to design a continuous production facility with enough flexibility, because if you talk about the manufacturing of pharmaceuticals, you have to put in a lot of different type of parameters, because each of these chemicals, they have a different different stability, a different lifetime, and different solubility and different solvents. Sometimes you want to use cells, sometimes or biological source. Sometimes you just want to use basically chemical synthesis. So there are so many things that that you need to take into consideration when you talk about continuous manufacturing, especially in this case that you are dealing with so many components together, that the stability of that is so important, because you cannot have a single parameter wrong, otherwise your drug would not work. So that's my take.
Yeah, thank you very much. So Karen, would you like to comment on it while the audience is voting?
Yeah, the audience is, I think they just started with voting. Yeah, about continuous manufacturing of pharmaceuticals. Yes, that is going to be a really big step if that can take place. There's also some legal issues that sometimes simply prevent changing a process over, because if it's an established process, then all of a sudden you're not allowed to change it anymore. So also there, in terms of what can be done in legal matters, I know that it's not process engineering, but it could be a way to get things allowed much more readily. If it's about continuous processing, there is a lot of continuous processing in food or in chemical industry or wherever. So I do feel that the field as such is quite well established. It's just bringing it to the pharma field with all the different issues that then would need to still be solved. But I'm very hopeful that this can be a reality.
Yes, thank you. And I fully agree with your comment on the legal aspect, because as if you want to think about a process, inventing a new process in an industry that is tightly regulated, like pharmaceuticals, you have to really worry about this. Yeah, thank you very much. So I would like to also give the last word to Michael. Michael, would you like to comment on this?
Yeah, so I'm not an expert on pharmaceutical manufacturing, but I do know that also in foods, for the continuous processes, online quality control is still a big challenge. So I think that's also a very nice topic for the processing community to develop control mechanisms that we can online really measure the relevant, in the end, consumer relevant quality attributes of our products.
Yes. Yeah. Thank you very much, Michael. Meanwhile, I see that Frank Smets has a comment about this. Frank, would you like to unmute your microphone and share your comment with us?
Yeah, well, I think the flexibility and then the constraint, the legal constraints in the actual business model of the pharma is that if they scale up to higher rates, they develop, in fact, a new process. And I think microfluidics may be a solution to that. And that will enable pharmaceuticals to develop something and get the legal acceptance for the process and keep the process, but by massively multiplying the process, which is possible in microfluidics, you can scale up in a very easy way, and that makes it also easier and possible to go into personalized medicine as well.
Yes.
To cut a few corners.
Yeah, thank you very much, Frank. So to add to Frank's comment, I indeed see his point, but we also have to think a bit about why the pharmaceutical industry is, let's say, is sticking to what they know. And so that's an interesting question. So if we can maybe understand why they are doing this, then this can lead us to innovate in the way that the new ideas such as microfluidics or other ideas developed on the way can be applied to the pharmaceutical industry. So, and I think it's not an entirely crazy idea for us to invent some of the researchers that are very much involved in these questions to learn about it, because my experience is that there are at least 3 major centers in the world that are dedicated to continuous manufacturing of pharmaceuticals. And there is no solution that fits all. So it might be interesting for us to learn from the existing collaboration centers for us to collaborate more efficiently on this. And meanwhile, I think Stefan has a comment on what Frank is saying. Would you like to unmute your microphone and join the discussion, Stefan?
Sorry, no, this was referring to the previous point about the fermenting processes. So
perfect, no problem. So then, with this, I would like to conclude our discussion, unless there are any burning questions in the last minute or comments. I see that the question, the answer from the public to the question that was posed is predominantly C, to design a continuous production facility with high enough flexibility. And this is indeed an interesting question. Of course, one can think about flexibility to what, right? So feed, we talked about in the food industry, major changes from meat-based to the plant-based. And for the pharmaceutical industry, this flexibility might be related to the consumer demand. Right? So also there is a lot of new trends in the pharmaceutical industry. So, you know, maybe 50, 60 years ago, pharmaceutical industry was only small molecules. Now there is a lot of larger molecules that are coming into play, such as monoclonal antibodies. That's I think also a relevant thing to think about. And I see intimate links between the food industry, what Karen and Michael mentioned, and the pharmaceutical industry, because the problems, the challenges, if you will, are very much parallel. You also don't want to heat damage or shear damage your products as you process them. This might be for us a interesting point to cross share information across the maybe industries. With this, I would like to end the discussion and give the word to Isabel. Isabel, can you please unmute your microphone and
yeah, sure. I hope you can hear me.
Thank you very much, Isabel. So before I give the would like to thank the panelists, Karen, Alina, and Michael. Thank you very much for a very nice, lively discussion. I hope this was useful for also the audience. Thank you very much. So we can also give ourselves a digital applause, if you will. Thank you for a very nice discussion. Isabel, the floor is yours, please.
Yeah, so we'd like to close this part of the panel discussion, and we will have a networking session after this part. So if you still have time, feel free to stick around. We'll also have one presentation then. And then I would, of course, like to thank the panel members and the moderator for this interesting discussion, and ISPT for the support in having this webinar online this year. And I think we have a second slide. So all the webinars we had, so we had 4 in total, are recorded and you can view them online. So Eva, maybe you can next slide. Yeah, and you can also check out the panel members we had in the different webinars, and then we hope to see you all face-to-face next year when we host the NPS in Delft again in the beginning of November. So I think for now it's planned on the 8th and 9th of November in 2021. Yeah, and then I would like to give the word to Hanif, who will now moderate the networking session. Yeah. Hanif, okay, if you can unmute yourself.
Yeah, thank you, Sybil. Hi, everyone. Welcome to the network. Yeah, we are really looking forward to leave. Please stay there for a few more moments. So for the first-time participants in the networking sections, it's an opportunity for the interested postdoc and PhD researchers to give a short pitch of their research so that they get some leads from the experts in the audience and also from the people who work in the similar area. Also for you participants, it's an opportunity to expand your networks, but unfortunately we have to do it virtually, so there are limitations. And myself, Hanif Shijaz, I may be the one last face you never got to see in the last 4 weeks. So for the participants who have been attending all the main webinars and the networking sections, that was an achievement because you got to see all the members of our organizing committee. So that doesn't happen very often in the virtual conferences now. So at least you know where to give your complaints for all these organizational problems for 2 years of NPS, 2020 and 2021. They don't really fire us for what you have done, what we have done this year. So anyway, it's a time to invite today's speaker. I think we have one presentation today. It's Vikram Kode from TU Delft. Hi Vikram, are you there?
Yes, I'm there.
Yeah, hi Vikram, welcome to the networking section and thanks a lot for volunteering with your presentation. So can you start sharing your screen? Let's see whether it works.
Maybe I'll have to. How do I have to share? Is it like through?
You can see.
Yeah, I got it. Can you see my screen now?
Yes, we can see your screen now. You can put on your camera and maybe you can start with a short introduction of yourself, then go to your pitch. All the best.
Yeah, perfect. Yeah, so hello everyone. My name is Vikram Koride. I'm currently doing my PhD in TU Delft under the guidance of Dr. Burak Eral in the Process and Energy Department of 3ME faculty in the TU Delft. Okay, so here is my pitch. As you see in this picture, crystals are beautiful, isn't it? But one of the most important challenges in the field of industrial crystallization, especially in the field of pharmaceutical or fine specialty chemical sector, is the crystal morphology, crystal size distribution, crystal purity, and crystal polymorphism. Also referred to as 4 pillars of crystal engineering to achieve good product quality. An answer to this question lies in understanding the primary nucleation mechanism behind this crystal formation. When I say primary nucleation, here it refers to formation of a new substance from another substance, like liquid water from solid ice. So therefore, my research revolves around understanding this primary nucleation mechanism for one such crystallization process, referred to as NPLN, standing for non-photochemical laser-induced nucleation. But why NPLN and what makes it so special? Because NPLN is a method to control primary nucleation both spatially and temporally using short pulses of laser light at visible or near infrared wavelengths. As you can see in this picture, when a 7 nanosecond laser light is passed through a 10 ml vial of supersaturated solution of potassium chloride, we see crystals instantaneously after 1 second. But the same solution, when not irradiated with light, takes over 2 weeks to crystallize. Therefore, through this research, I would like to understand the importance of this mechanistic understanding of NPLN by combining experiments with theory. Finally, by connecting this insights from this fundamental understanding of NPLM, allows us to integrate this part as an important control tool in this industrial crystallization to generate desired high quality crystals. Yeah, if you have any more questions, you can reach out to me on my LinkedIn account. I would be happy to share with you on further details. Thank you for the opportunity.
Thanks, Vikram, for the super fast speech. So is there any question for Vikram in the chat?
Yeah, because I was told it's for 2 minutes, so hence I had to make it like
yeah,
in a
it's
short.
okay. Yeah, I think that's enough to get your message across, and we expect to see some questions here.
Yeah, I would be glad to.
And I don't see anyone raise their hand. So Vikram, would you like to ask, talk to a participants you already know? You want to get some feedback on that?
Yeah, I mean, like I just wanted to ask, like this is my first as such conference because I'm in my first year of PhD, almost finishing it. So it's a nice experience for me to understand how this works and to tell about my project to a rather bigger audience. So yeah, I see my supervisor is asking me a question. How does NPLN work? So where it can be useful.
Yeah,
So,
there's a question by Burak. If Burak wants to ask, and you can unmute your microphone and ask. Then, yeah, he can answer.
Sure. Hi. So, of course, I'm a bit biased about this particular project. So, I would like to maybe chat a bit more about the possibilities. Because we discussed a lot about plant-based proteins and how processes should be adjusted once you change from meat-based products to plant-based products. Do you foresee any opportunities for NPLM to be used?
Yeah, good question. Personally, I think currently NPLN is targeted towards pharmaceuticals, but on a longer run, we still haven't processed many such chemicals. But yeah, I mean, I think it can be used, but yeah, given the limitations that we can see with pharmaceuticals, maybe the future can answer how far can we use with food-related products. Yes.
Yeah, thanks, Vikram. There comes some comments like they couldn't see you. Actually, your camera was still off. But is there any questions? Any more questions for Vikram from the chat? Yeah, now we can see Vikram.
Yeah.
So I think there are no more questions in the chat.
There is a question.
There's a question from Marike. So Marike, can you sit and ask your question?
Thank you. I had a question on what your definition of a good crystal is and how you want to evaluate a good crystal.
Okay, so that's a nice question. For me, the crystal is basically something that has a size limitation. Like let's say a product quality is defined by 4 major areas. One is what is the size of it, and what is the purity of it, and what is the morphology of it. So that's how I treat it as a good crystal. And if I say I want a crystal of, let's say, 100 microns, I want it to be as precise as possible with that definition of size. So yeah, that's what I call it a good crystal.
And what type of analytics do you usually use for this? Is it industry standard or?
Yeah, so mostly we talk from the consumer understanding, like what is the thing that he wants or she wants, and from that we talk from industry standards. Yes.
And if you think about crystallization, especially for pharmaceutics or small pharmaceutical products, it's used quite often. So what type of crystallization processes do you want to substitute with this particular?
Yes, so currently, if you see on an industrial scale, mainly it's a cooling crystallization, which has been like performed for a long time. So, but this involves like batch cooling crystallization, which is like, I mean, people are getting answers to it, but still it's very difficult to control all important parameters which are varying over time. So in my method, I'm not doing anything with respect to the sample as such. I use an external source in the form of electromagnetic irradiation, like light, and potentially substitute it with LED, let's say. If we can use this LED to crystallize these materials, that would be like a new revolution in this pharmaceutical industries, because currently people are spending millions and billions of euros to, you know, achieve the required product sizes or, you know, the product qualities. So if we can get through this method by deeper understanding, I think that would be a new revolution, in my opinion. Yes.
Can I ask one last question?
Yes, sure.
I think you focus on small molecules pharmaceutics. Or do you also foresee issues when you work, for example, with proteins as a pharmaceutical product, when you use a laser?
Yes, I mean, to answer the first question, like N-pilin has already been used for like small molecules, but when I talk about femtosecond lasers, they've already started using for crystallizing proteins as such.
Okay.
So it's like a broad field where some of the proteins like histidine, lysosome, all these have been crystallized using this method. So it's not a new field altogether, but like they have been targeted towards small molecules now, but eventually it will be scaled up towards other long molecules also, including monoclonal antibodies.
Ah, interesting. Okay,
yes.
Thank you for your answers. Thank you.
Yeah, thank you.
Thank you, Marike, for that discussion. So, is there any more questions for Vikram? Or from the side of Vikram, would you like to say something? Or
Yeah, this is a nice opportunity for me to showcase like whatever I wanted to tell, also like to understand what other people are working and to get a more understanding from, you know, different ideas and how like people are working with different passion to make a world a better place in terms of living and yeah, many things. Yeah, it's a nice opportunity. Thank you for everything.
yeah, thanks, Vikram, for that. So I see there are no other questions. So if you like to connect to the audience further, you can always contact us. We'll let you do that.
Sure.
And with that, yeah, then it's time to wrap it up. So we leave you all there for another 1 year with a lot of excitement and hope to see you all in person the next year at TU Delft, the grand NPS event. So till then, thank you so much, especially for staying back for this networking session and for your participation in all other webinars and networking sessions. So thank you so much.